welcome back. In this video, in the rest of this video, we will be talking about the general rules of exponent. So first thing first, anything to the power 0, whether a base, a variable base, or a constant base to the power 0, it's always equal to 1. Okay, that's a very important rule. The other one concerns the negative exponent. So a to the power negative n equals to 1 over the same thing, but this time the exponent sign is flipped. So that would be 1 over a to the power n. Rule number 3 is actually derived from rule number 2. So if we move an exponent from denominator to numerator or vice versa, the sign will be flipped. That's the only thing which will happen. The next one, it's a to the power m raised to the power m. That means a to the power m, it's multiplied by itself n times. So here, that would be a to the power mn. Okay. Again, rule number 5 is indirectly derived from rule number 2. So here, what I can do, I can bring this guy from the denominator to numerator, and I can do the same thing but this time from numerator to denominator and turn it to positive exponent. Next thing would be rule number 6. Again, it's regarding negative exponent. So here, if you consider only the negative sign, I can just flip, this function, raise it to, well, actually what I'm doing is raising it to the power -1, then raise it to the power m. Let me just expand it. So a to the power b can be raised to the power -1. Then after that, I will raise it to the power m. That's exactly rule number 4. Can you see this one? So m and n, it's multiplied. So here again, when it's multiplied, it's -m. So what I can do here, first thing, I will deal with the inside one. So inside would be b over a to the power 1 and then raised to the power m. Now 7 and 8 are extremely important. I want you to put a star next to it. So here we have an exponent, and then afterward we are taking the nth root. So here a to the power m, it's under the radical sign, and then outside we are taking the nth root. So what we can do here, the base, right? We write down the base, and the exponent would be m from inside moving toward outside, m divided by n. Or some people simply prefer to write or choose one of these formats. It's exactly the same thing. So if you use rule number 4, you would see that this will give you exactly this one, and this one will give you exactly the other two. Rule number 8 is also derived from rule number 7. So here, instead of one variable, we have two variables. Again, from inside, it's 1, and then move toward outside, it's 1 over n. Okay, this is a very important point. The rest of this handout is a summary of exponential rules. That's very useful. I will be sharing this one with you guys on the Brightspace, so you can just go over it. But remember, the only way you can succeed with math is through doing practice. Okay, now let's continue with exponential expression. This is the general form, a b to the power x, okay, where x and a are real numbers and a is never 0, because if a is 0, then the whole thing would be equal to 0, okay? And here we would know that b is a member of the real number, and it should be greater than 0. It should not be equal to 1, and b is called the base. Okay, So in other words, A is the coefficient, right? Coefficient of the exponential function, and B is the base, and X is the power, or even sometimes they call it exponent. Okay, now remember guys, so there are some limitation here. There are A can never be 0, okay, but for B there are more conditions. So the B, first of all, should be a member of the real number. It must be greater than 0, and it must not be equal to 1. So this one and this one. And so B is called a base. This is an exponential expression. Okay, so during each type of function, we will see how we can simplify it, how we can graph it, what is the range, what is the domain. These are all the things we have to learn about each type or category of functions or expressions. Last sessions we learned that the last couple of sessions we learned about the quadratic function. We learned how to actually graph it, find the domain, find the range, and again today we will learn about this exponential function or expressions. And these are the typical questions that you will be given under the exponential expression. So let's start with question 1. As you can see, you are given 27 to the power 2x, and the question is asking you to convert each of the following to the base indicated. Okay, let's see. So here, first of all, this is your original given function. 27 is the base, and the power is 2x. Okay, but the question is asking you to change the base from 27 to 3. What I know, I can put it as a side note. 27 is 3 to the power 3. Okay, and this is what the question is asking me. The question is asking me to change the base to 3. So here, what I will do, I just replace 27 with 3 to the power 3. Let's see. So I have 3 to the power 3 replaced by 27, okay? And then I have 2x sitting outside. Remember this rule? If you refer back to the general rules, I think it was rule number 4, right? We will apply rule number 4 here, and then we will get the answer. Okay, so rule number 4, remember, compare it again, rule number 4. So the answer is 3 to the power 6x. So 3 to the power 6x is exactly equal to 27 to the power 2x. The only difference here is that the base is 27, here the base is 3. The reason why we're changing the base, sometimes working with a smaller bases are easier. Sometimes we want to simplify, solve equation. It depends on the application. Let's move on to the next question. So in the next question is asking you 125, the base is 125, and then it's asking you to change the base to 5. Okay, so remember 125 is 5 to the power 3. Okay, I'll do exactly the same thing here. So I write 5 to the power 3, and then outside I have 1 minus x, right? So here, again, that's exactly, exactly the same rule, rule number 4. So that would be 5, 3 times 1 minus x. That is your answer. Okay. Now let's move on to part C. Here you have 4 multiplied, 64 is the base, and then the exponent is x over 2. So the 4 is the coefficient, 64 is the base, and the question is asking you to change it to base 2. Okay, so what is the base here? 64. So I just write it down here. 64 is actually 2 to the power 6. How do I know? It comes with practice. Okay, so 64, I just expand this guy. So 4, 2 to the power 6, replace it, x to the power 2. Okay, so 4 multiplied 2, 6 times x divided by 2. So that would be 4. This will simplify. That would be 4, and then I have 2 to the power 3x. So 4 to the power 1. What I can do here, 4 to the power 1, I can rewrite it as 2 to the power 2 and then simplify it. I have the same base. What I will do, I will just add them together. Okay. Moving on to the next question, 1 over 256, and the exponent is 3x. Okay, so here what I will do, I'll show you something. 256, and then it's asking you to change it into base 2. What you can do, you can divide it by 2. It would be 128. Divided by 2, 64. Divided by 2, 32. Divided by 2, 16. Right? Again, we continue. Divided by 2, 8. Divided by 2, 4. Divided by 2, 2. Right? And then 2 divided by 2 can be divided by another 2. That's 1. So let's see how many 2's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you could say 256 is 2 to the power 8. Now let's substitute it. 1 over 2 to the power 8. I have 3 to the power x here. Now let's simplify it. 1 over 8 times 3x, which is 24x. Or if you prefer to have like another function, you can move this up to the numerator and makes it negative. Okay, next question, you have 1 over 4 multiplied by 1 over 16 to base 4. Here, what I will do, 116, it's actually 4 to the power 2. So I just write it 1 over 4, which is the coefficient. 1 over 4 to the power 2, and then 4 minus x. Right? So I just write it down here again. This guy will be raised to this one, which is, again, that would be 1. 1 raised to any power still equals 1. Now here, 4 to the power 2 raised to the power this guy, which would be 4, 8 minus 2x. Okay, remember, I can simplify it further because this one, the power is 1. So that would be 4. 1 plus 8 is 9 minus 2x. If you want to play around, you can move it up. But here that would be minus 9 plus 2x. You can see how many different forms you can rewrite it. And it's exactly the same thing. Okay, the only reason we have different formats or we are trying to convert from one form to another is to make it simpler. Next question, it's giving you a base, which is a fraction, and it's asking you to change the base to a different fraction. So here you have 81 over 16, and it's asking you to change it to this base. So 81 is actually 3 to the power 4, and 16 is 2 to the power 4. So I can write it as 3 over 2 to the power 4, right? So here, basically, what I'll do, I'll just write it 3 to the power 3 over 2 to the power 4, and then I have 5 plus x sitting outside. So if I want to simplify it, again, rule number 4, these two will be multiplied. I can either write it like this or this. It's up to you guys. Now the next question, it's asking you, so the base is 25 over 49, but the question is asking you to change it to 7 over 5. So what you can see here, 25, it's 5 to the power 2, and then 49, it's 7 to the power 2. So that would be 5 over 7 to the power 2. But remember, if I make this exponent negative, the base will be flipped, right? So that would be, I can write it down as 7 over 5 to the power negative 2. Do you guys agree? So 25 over 49 would be 7 over 5 to the power negative 2. What I'll do here, I just bring it down here. So I just write 7 over 5 to the power negative 2. And then the whole thing should be raised to the power 3x. So that would be 7 over 5 negative 6x. But if you want, you can get, okay. You can either stop here or just, I want to show you something, because the question is asking you explicitly to write the base as 7 over 5, but I just want to show you something. You can just rewrite it as 5 over 7, 6x. Please tune in back for the rest of this topic on exponential. I will do it in another video because this video will be too long. See you soon.